Hello everyone. Once again I welcome you all in this video session. So in these two subjects like advanced manufacturing processes and the fundamentals of manufacturing processes, we were discussing about the unit number 5 and we have discussed two lectures on these on this unit. Okay, so in which we have discussed about the different types of the 3D printing technologies or the techniques that is available to us that I have briefed you. Okay, so in this lecture, we are going to discuss about the how exactly the 3D printing is done. Okay, means there are like basically three steps. So in first step we will go through, we will prepare a model in the Solidworks. Okay, second step, we will convert that whatever the STL file that we have saved, that we will convert that into the GCode file. Okay, and after that we will take on a that file on a 3D printer. Okay, so I will try to take 5 or 10 minute sample whatever we will prepare, okay, on the SolidWorks. And this is how like you can get an idea that how exactly that the 3D printing is works. Okay, so let's start. Okay guys, so this is the SolidWorks which is like, okay guys, for the time being, I'm just turning off my video. So this is the SolidWorks. Okay, so from here we have to select the new file, and here it's like part assembly and the drawing operation is available. So in the part we'll create, we usually create the 3D models. Once 2D models, then we are converting that into the 3D models, and then we have assembly portion. So whatever the parts that we have prepared, if you want to assemble them, then we will choose this one. Okay, or like whatever the as you have gone through the engineering graphics and design or engineering drawing subjects in the first or second semester. So whatever the 3D print in drawing, basically what we are doing is we are creating the just 3D models on the 2D drawing. Okay, so uh, like we are using the front view, top view, side view, means whether it's right or left side, so that we are creating. So whatever the 3D files we have, we can directly extract on a drawing. Okay, but here our purpose is to make a 3D model, so I'm just using drawing part modeling. Okay, so guys, I'm not going that much into detail for the SolidWorks because this session is not for the SolidWorks. Okay, so first, first of all, in SolidWorks we have to choose the plane. So we are just selected that top plane and sketch and normal to that, and we are just drawing a simple hollow cylinder. Okay, so I'm just selecting that one. So here we have chosen the cylinder. Okay guys, now here I'm choosing the smart dimensions. So exactly it is like 100 119 mm around. So just make it 100 because 100 mm itself is a large size. But we'll see how much time is required to make this whatever this hollow cylinder that we are going to make. Okay, and accordingly we will reduce that in the Cura software. Okay, so this is like we have prepared, and like let's go to the extrude part. And this is here we can give the dimension. So thicknesses, I'm taking this 20 mm. Okay, now this is done. Again we have to make it hollow. So again I'm going to the selecting this plane, and this is perpendicular. Again just select the circle, center base circle, and I'm creating this one. Okay, again go to the smart dimension and choose it. Like this is 60, so I'm taking this 70. Fine, so this is 70 I have taken. And now what we have to do, we have to extract this extrude cut. We have to provide the extrude cut. Okay, so extrude cut is like I'm choosing up to the through all. So whatever the thickness or the yeah, depth we can say, up to that it will reduce. So this will looks like this. Okay, so this is the ring basically, or this is a hollow cylinder that we have to create in a on a 3D printer. Fine, so now here is the save option is available. So select is save as. And as I told you that that what file we have to choose. If you will not choose any file, then it will be saved in .prt file. Okay, or solid prt, means sldprt. Okay, and but here we have to take this stl format. Okay, in stl format we have to be saved because generally whatever the files that is that is read by the 3D printers, that is STL only, that is by the G code. But whatever the software that is available to us, that read the STL format. Okay, means STL means standard triangulated language. Fine. So that is select, and I'm just giving the name, that is H underscore C. That is, sorry, this is some else has been selected. So I'm selecting this STL format. Okay, guys, and here I'm giving this name, that is H underscore C. Okay, hollow cylinder. Fine. So this is save. Where exactly it is saved? This is save on, yeah, this is save on desktop. Fine. So now if you will see this one, the geometry of this cylinder, it looks like that this is the triangles, this is converted into these triangles, right? You can see here, from here you can see that this is, these are the triangles. Okay, these are the triangles. So this is converted into the triangles. This is a triangle, this is a triangle. Okay, this is a triangle. So these are all combination of these triangles. Okay, fine. So now let's move to the next software, which is the Ultimaker software, that is Cura. Okay, so let's okay, so this is the software. First of all, I'm just briefing this, what these terminology that is okay mentioned here. So this is the file option, that whatever the file that we have to extract, so we can extract from our computer, wherever drive we have saved that one. This is this is a common software for the Ultimaker 3 and Ultimaker 5s, because this is the old version and this is the new version. So the common software we can use, but just we have to select the 3D printer which on which we are working. So we have this Ultimaker 3, so we are selecting that one. Now here, as I mentioned in the beginning, that there are two nozzles we have. Okay, and one nozzle can also be possible, but it depends that what like supporting material, whenever we have to provide, we need the another nozzle, or one from one also can be manageable. Okay, but if you want to deposit separate material apart from the material, main material, supporting material is different, then we have to choose the another nozzle. Okay, so these are the two nozzles. So first we are selecting this white PLA. Okay, and here you can select these different types of the materials, which is from here, that ABS, breakaway, CPE, PC, PLA, PVA. Okay, PVA generally we are using for the supporting material. So and here the print core, which is like which is of the dimension of zero point 0.4 mm that we are choosing. Okay, now here you can select this one. So this will show you the data of the second nozzle. Okay, so here also, like, we have selected this PLA, white PLA, but it should be like, if we are choosing this white PLA in one, then we have to choose the another roller. Okay, another filament roller on the second one. Okay, so there will be a separate material we have to choose. Separate means, if you are choosing supporting material PLA only, then we can choose, but we have to be mount another roller. Okay, two separate roller. Fine. Here, if we have to provide this supporting material, then we can choose this PVA as well. Okay, but here we are not, because here in this case it's not needed, so we are not taking that one. Okay, this is Ultimaker, this is PLA and white PLA. Okay, that we are taking, right? Now here, okay, so this is not supporting, so let's remove it. Just remove this one. Fine. Now here, the quantities that we have to choose, that profile, that what profile exactly we needed, whether we need a extra fine, normal and fast, means exact outer shape thickness is how much we needed. This is 0.06 mm. These are the length. This is the size which is available in these categories. So that we have, that we can choose. So we are here. We are choosing this fine. Okay. Here the quality. This is quality means the layer height. That, as we said, as I said, that fine means the thickness of or height of this filament that is coming out. That would be like zero point 0.1 mm, 0.1 mm. Okay, so that will be deposited, right? So walls is uh, how much, like, wall thickness we are taking 1 mm. Okay, so and wall line count means how many how much lines we needed, okay, of this thickness. So this is, we have chosen 3, right? Here also, like, we can choose like a top and bottom thickness, means because this, whatever the solid materials that we are making, okay, which needed, means it should be looks like it should be like solid from the outside. Okay, so that bottom thickness and the top thickness here we can choose. We are giving here 1 mm thickness, okay. And what is the layer, how much layer we needed, means top layer we needed how much, okay. So this is 10 is mentioned, okay. This is 1 mm, so let's select like 5 only, so let's make it 5. Okay, let's make it 5, fine. Next is infill. Infill means how much, like if we'll choose the 100% here, it means that that whatever the solid, whatever the product that we are going to manufacture on the 3D printer, that will be complete fill of this filament. Okay, that will be complete fill of this filament, right? And if we are reducing it to 20% here, then whatever, when you will weight it, like it will be 20% of that solid only, right? So 20% infill density only we are using. Now here the infill patterns, that what types of the pattern, this nozzle will move inside the and it will fill the material. By the way, when it will print, this 3D printing will printing, that time I will show you that how exactly it is printing. So there is number of options are available: grid, lines, triangles, tri-hexagonal, cubic, octet, concentric, zigzag, cross 3D, gyroid, and this triangle. So here we are selecting this triangle. You can choose any one of them, okay. The material that we are depositing, so whatever the material that we have selected, that has a printing temperature that is 200 degrees centigrade, and the build plate, that is bottom of that, okay. Over that, from that basically we start this printing, so that temperature is 60 degree, okay, that is needed. Speed is also like 50 to 70 mm per second is a common or good speed that we are considering, okay. Or you can increase it up to 100 mm as well, okay. Here the important thing is another is like supporting material. So here we are not using the supporting material, but you can select this supporting material from generate the support by clicking over here or selecting it, okay. So wherever you need it, like everywhere, or the touching build plate only, means on the, when it will start building the material, the solid material from the bottom plate, that time it will start only there, only you need the supporting material, or everywhere. So everywhere we are selecting, but here we do not want that supporting material, so we are not selecting that one, okay. So now just select it and just bring it model, okay. So this is on desktop, so we saved with HC, right? So this is how like this model is looks like. Okay, so this is how, this is the, like we have brought the model over here. Now whatever the data that we have chosen, simply like you can go for a slicing operation, okay. Here you can just choose the slice, and it will show you that when you will take these dimensions, okay, when you will take these dimensions, it will take 7 hours 17 minutes, okay, and it will consume 38 grams of the material. And is this filament that we are using, that is made up of the 2.75 mm diameter. So 4.75 meter will be required in length, okay. So what we are doing is we are selecting it one. Now first of all I'm showing that what other options are available apart from this related with this one. So here this is the first option. So if you will see red color, this red color is x direction, this y color is y direction, sorry, green color is y direction, and this blue is the z direction, right? So generally this is generally it is 0 0 only, but minor error is there in the x direction. So from center origin it is kept 0.0673 mm apart, okay. Here scales are available, so different scales like here like in x direction and in the z direction, okay. This is towards the radial direction, right? So radial is diameter, and diameter we kept is 100 initially, right? And the thickness, that y direction is the thickness, so that thickness we kept, that is 20 mm. So like here you can get this 20 mm, right? Here the rotation is available exactly like if we use this one, like for an example, here like this is the ring, right? This is the ring, and when we will start filling the material, like it will start filling this one. So as it will move this side, this curve surface will come, okay. So here it has to be deposit the material, it has to be depositing the supporting material, right? Also like when it will reach up to here, this curve shape will come inside, right? This curve shape will come inside. So from here only it will start depositing the supporting material, right? So whether this supporting material can be of just a minute, like this supporting material can be of whether it's a PLA only or we are using another material. Okay, if we are using the PLA material, then we can reduce the density of that, means infill density, so that less amount of the material will be deposited, or we can use another material, right? So this is the supporting. Here if we'll go for a machining manufacturing like this, in this uh, like in this projection or in this view, then it will be like it will take around this much of the material, like 38 grams. Okay, let's rotate its dimension. What I'm doing is I'm just rotating its dimension. So now this has been reduced. Now it will looks like this. Okay. Like looks like this. Okay, so let's go to the slicing operation. So now it has been reduced to 37 gram, little bit of 1 gram has been reduced, and it will take 4.65 meter in length. Okay, and the time that is required, that is 6 hour and 5 minutes. Now this time and the material is reduced because whatever the material that time that is extra material showing in during that time, so that is basically the supporting material. Now when we will go for a manufacturing of during this projection, there will be no supporting material is required, right? So again select this one. What we are doing is we are reducing its dimensions. Okay, so here we are choosing this uniform scaling, or if you want to go for like a different, like x direction ka kuch aur rakhna hai, y mein kuch aur, z mein kuch aur, so here you can go for a snap scaling, but I'm choosing this uniform scaling. Okay, so I'm just selecting this, like just make it 50%, so it will be reduced like 50 50 50, right? So now let's go for a slicing operation, that how much time it will be needed. So it will take 1 hour 20 minutes, but still for this class or lecture it is more. Okay, so again I'm selecting this one and I'm reducing it to 20%. Okay, and just select it that how much time is required. So it will take 11 minutes. Okay, and 1 gram of the material is required, and this is length, that is zero point 0.1 meter. Okay, 0.11 meter. So I'm just saving this one to the disk, but disk is not, let me take. I'm just taking it to the pen drive. Okay, so directly we can use this pen drive to the 3D printer. Okay, so here it will show you the save to the remote disk, or in any other disk you have to be, or drive you have to be saved. So I'm just saving that into the removal disk. So here it has been showing the file save to removal drive. Okay, with the name that is um3 underscore h underscore g c. Okay, dot gcode dot gz. Okay, now it means that this file now is converted into the G code. Exactly how we insert it, we insert it into STL format. Now it is converted into the G code. Fine, now just eject it, and like this is done. Okay guys, so now my video will be on, my video will be off. Okay, this because I want to show you this video. So this is the like 3D printer. Now you can see here. Okay, and like okay, so on the screen I'm showing, this is basically here, this is basically the LCD. Okay, so here three options is available, that is print, material print core. Okay, material print core, and the last one is the system. So like whatever the material that we have to print, so first accordingly we have to choose this print option. Okay, if we have to change the material or load the material, okay, or if we have to do anything active, other activities with the nozzle, okay, then we'll go for this, we'll select this option, that is material order print core. Or if you want to change the system, or here like we have to connect other connectivities, then we'll go select this system. But here in this video our option is up to the print only. Okay, here this roller is given to you, that is it will just like when you will rotate it, it will move up and down, right? Okay, so like whatever the wherever like you have to select the print, so just press it. Okay, wherever. Now here two options is available, that either you can connect this USB, okay, that pen drive, and you can connect you can take the file from the Wi-Fi as well, right? So here what I'm doing is I'm taking this pen drive. Okay, so this pen drive is I have kept, And before going to that, I just want to take before going to print, I just want to take here that if you will see this one, then this is basically the nozzle. So this is the one nozzle and this is the another nozzle. Okay, this is the second one. This is the second one. Okay. Now here you can see that these are the two nozzles. From here you can see this is the first one and this is second one. Once it will start heating, it will become red. Okay. Now it is blue because it's a cold. Okay. So now here, if you will see this one, this setup, then this is the filament which is coming. Okay, this one is the filament which is coming, and if you will see, this is a here it's basically the stepper motor is mounted. Okay, this is the stepper motor. So basically it is feeding inside this material. Okay, now this, if you will see this one, this material is coming from this roller. Okay, so this is the roller. This is the roller where we have, this is the roller where we have keep this one, and this another option is also available. So over, like over this one, if you want to provide the supporting material or any other kind of material to the nozzle, okay, through this one, through this facility, through this stepper motor. Okay, so this is also, like from this also we can insert that one. Okay, but here we are talking about only one of the material. Okay, so okay, guys. So now we are selecting it one by one. Fine. So this is like print. Okay, this is as we will rotate it. As you will rotate it, rotate this one, then it will move up and down. And here it will. I'm showing uh, this as a print. Okay. Okay. So this is showing the print. Okay. So now just click on that. Now it is we have click on that. So first, this, like there are number of files is saved. So if, when you will rotate it, it will show you the number of files. Okay, right. So here basically what we have to do is, here we have to select this um3 and underscore h underscore c. So let's, if you want to go back, then this return option is available, right? So now it's main window, right? So again, go to the print, select it. Now here, first only latest, which is because we have saved this option latest only. So it will show you in the first beginning. Okay, that is underscore h underscore c, right? So just okay, I'm just selecting that one. Okay, so this is selected. Now it is showing the preparing to print. Okay, so it's now this nozzle is moving, heating the build-up plate. This is basically the build-up plate, so it is moving. Okay, backside to that, this is basically the rack. Okay, so that cylindrical rack. Okay, so that is basically moving in z direction. For x direction, this is provided. Okay, and for y direction, this one is provided. Okay, so now it is heating the build-up plate. It will take a little time, so that time for to reduce that time, just stopping. So it is about to complete. It will take because it's very cold. That's why it's taking time. Because as we mentioned in the it is it the that in the software it was mentioned that it will take like 60 degrees centigrade, 60 degree. Okay, so that is because it is heating, so 5 7 degrees centigrade, it's cold, that's why it will take a little bit time. That's why it took. And now it is heating the print core. Print core means the nozzle basically. Okay, so again now it will not take that much time because heating takes place uh, during that time only it will melt the material. Okay, now it is moving towards you see that it is, the printing has been started. You will see, if you will see the screen, then it will show you that how much time is required. Okay, so it is mentioned here that it will take 11 minutes and 2 seconds. Now it's 1 second, then 10 minutes and 57 seconds. So it will, this time will be show on the screen. Okay, so it will take 10 minutes to print like this. Okay, in between, like I will not aid this complete video because it will the length of this lecture will be increased otherwise. So I'm just uh, because this process will this 3D printer will move like this only. Okay, so in between, like after 2 minutes I will again again I will aid this one. Okay, again I will start and you will get an idea. From top view I will show you that how exactly it is working. Okay, so let's for 1 minute you can. Yeah, this is printing is going on. So I just want to take this one to see this how exactly on the top it is working. Here on the side, basically, we can see that this printing is going on, and actually there were some options were there that supporting material. How we want to provide this supporting material. So this supporting material, like number of ways we can provide. We can provide, right? Right. So this is how the printing is going on. Okay, and again it will take around 6 more minutes. So I will show you after 2 3 minutes again. From here, you can take this idea that the thickness of this uh, the model that we are making that is increasing. Okay, so So it will take 4 more minutes. After 1 minute, after 2 minutes, I will start again. So now it's almost done. So now it's done, and on the screen, like you can see that this printed now the cooling. This is basically cooling the printing core. Okay, nozzle that was around 200 degrees centigrade. So now it is reducing, and the build-up plate is also, and that has been finalized. So the this has been ready. So here we can reduce this. We can remove this one. Okay. Now it is another print is ready. So let's see. First we remove that what exactly it has been printed and what the drawing that we do. Okay. So this is the top view. Okay, there is a small ring that has been created on a 3D printer. Okay, so here if you will see this outside, so this is basically this brim and all these things. Okay, that how much whatever the model that we are creating, little bit tolerance we are keeping so that the material should start sticking from on the build-up plate from little bit distance. Okay, so that there will be a no problem to the our main object. Okay, so just I'm removing this one. Okay, so for the removing, just I'm stopping. Okay, this video. Okay, guys. So this is basically the ring that we have. That is our model basically. But it was like there was some this kind of shape was there. Okay, this is as I said that this is a supporting material that is printed on that. So this is supporting material can be removed after this one. Okay. Now as we did not provide any such kind of the supporting material in the beginning like PVA. So this supporting material is created by PLA only. Okay, so this is a 1 mm thickness that is reduced, and finally this is the ring that we get at the end. Okay, so still some kind of finishing is required, so either we can keep it on a chemical so that this or we'll rub this through the emery paper so that that we will get it. Okay, so thank you so much guys. I hope that every one of you will enjoy you enjoyed this lecture. Okay, and I also wish that those who enjoyed, and if you want to learn something, then you will prepare such kind of models in the future, and you will also come up like I want to make these kind of models. Okay guys, so thank you so much.